Robotics, episode 182. Last week in AI, bringing news to you. Alexa 2.0 on the billion for SI. OpenAI's chips, California, it's watchful live. Stay tuned, so much to it.
Hello. Quick message before the episode starts. As I mentioned in the last episode, we are in a bit of a catch-up phase. So this episode was recorded a week and a half ago and uses a bit out of date. And then in just a couple of days, I will be releasing the episode we recorded last week, which will have the exciting news regarding OpenAI's new model and other things like that. So apologies for the delay once again. I will try to stay up to date going forward. We try to record on Friday and release on Sunday, but sometimes things get in the way of that. Also, as you have been hearing, if you've been listening to the last couple episodes, more likely than not, for the next several episodes, Jeremie will not be co-hosting. He will be having, I suppose, a lot to do with a new baby on the way. So you can expect that. Hopefully, you will still like the episodes with the guest co-host. And just one last thing before we get going. We haven't had sponsors in a while, but we are going back to that. And we have a couple of things to mention in this episode and possibly in future episodes. Don't worry, we won't be promoting any vitamins. We're going to do our best to promote only things that are relevant to those interested in AI and tech. And that is definitely the case this week. The first thing I will mention is Agent.ai, which is a service where you can actually hire AI agents. And here's the text they would like me to read. Agent.ai is where the world discovers, builds, and hires AI agents to help them do more. Some of the tasks AI agents are doing for users include supercharging workflows, automating routine tasks, debugging complex issues in your codebase, creating memes for your tech blog or social media, and conducting in-depth research on companies or technologies. Agent.ai is built for builders. In fact, it was built by Dharmesh Shah, co-founder and CTO of HubSpot. Agent.ai is your best global marketplace for agents and the humans who build them. It's a platform where you can find and connect with AI agents that will help you get more stuff done. With Agent.ai, you're not just using AI, you're at the forefront of its growth. Join us. We're building the future of AI together. Sign up for Agent.ai at Agent.ai today and get 100 free credits so you can start building right away. So there you go. That's an interesting new effort that I suppose probably some of our listeners would find interesting. And just one more thing to mention before we get going. Another thing that we actually having a cross-promotion with another podcast that you may be interested in is Pioneers of AI. And here's the quick description of that. What will the AI revolution mean for jobs, for our kids, for our relationships and daily lives? A new podcast, Pioneers of AI, is your trusted guide to this emerging technology. Host Rana el Kaliouby is an AI scientist, entrepreneur, author, and investor exploring all the opportunities and questions AI brings into our lives. Listen to Pioneers of AI with new episodes every Wednesday, wherever you tune in. So once again, always fun to do a cross-promotion with another AI-focused podcast. And if that does sound intriguing to you, then go check it out. And that is it for this prologue. Please enjoy the actual episode. Hello and welcome to the latest episode of Last Week in AI, where you will hear us chat about what's going on with AI and, of course, specifically what's been going on with AI this past week and the most interesting and impactful news that happened. As always, I will mention you can also go to lastweekin.ai for the text newsletter, where we'll have all the other stories that happened this week that we are not covering. And also, by the way, if you don't know, if you subscribe to the newsletter, you also will get an email for each podcast episode, and that email will have all the stories, all the links. So that's another reason to check it out. Alrighty, and that being said, I am one of your hosts, Andrey Kurenkov. I finished my PhD at Stanford last year, and I now work at a generative AI startup.
And I'm your other host, Jeremie Harris, co-founder of Gladstone AI, an AI national security company, blah, 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 blah. Thank you for joining us for the podcast. We are going to have a shorter one today because as we're recording this a little bit later in the day than it is normally. And we'll see if we can actually do this. We keep saying this and then we don't do it. but
yeah,
we'll
we
see what
try.
happens.
The last few have been pretty long, and it's funny if I can skip to the listener comments. We got a few great reviews on Apple Podcasts. We have like 213 reviews now, which is wow. Thank you. I guess people did listen to me begging for a few more for 200. But one of them said, those reviews said, great show. Every episode without fail, Andrey announces onto a lightning round only to dive into a segment that's just as detailed as the rest. And that's been true. And that's why the episodes have been 2 hours long. But we'll see. Maybe this one will be a bit shorter. We shall see. A couple more shout outs on the reviews front. A few more comments saying appreciation for the geopolitics and for your perspective on hardware, Jeremie. So glad to hear people are into it. I think our policy is we will keep covering it, but we will try not to like inject too much China coverage in research segments and whatnot, where we can focus more on technical details. And you did get congratulations on becoming a dad soon, Jeremie.
Oh.
So there you go.
Wow, that's super sweet. Oh my God. You guys are just way too nice. Thank you. Thank you. I do, by the way, there is a comment that issues I think a good correction. I especially love the deep dives. Oh, sorry. No, that's the wrong one I was reading. Where was it? Anyway, so somebody was saying, Jeremie is too preoccupied with, where was it? Oh, too preoccupied with single-handedly preventing an AI apocalypse. So, tracking. And I will be sure not to be single-handedly preoccupied with stopping an AI apocalypse.
You got to get some other people to have some, like, I mean, a lot of people are working on it. Anthropic is doing some stuff.
It's a lot of pressure to be the only guy working on this. So, yeah, anyway, I will endeavor not to be. No, but appreciate it in all sincerity. I got it. So, yeah, this is going to be, I guess, a shorter episode. It's going to be an attempted shorter episode. And do we try to do faster lightning rounds? Is that part of the game here?
I think that's going to be part of the game. We're going to try and constrain ourselves to not talk about for like 5 minutes for every story. We'll see how it goes. Baby. Let's just start and see how it goes. And starting with tools and apps, we only have a couple stories for this segment. And the first one is kind of a big deal. The story is that Amazon picks Anthropic to power Alexa 2.0. So we've, I guess, heard about Alexa getting a chatbot type upgrade pretty soon. This is set to be released in October and will actually have a monthly subscription price between $5 to $10 per month. And interestingly, here Amazon did say that they are using Claude to power this new version of Alexa, which is interesting because they could have tried and created their own in-house technology. Presumably, they will have to pay Anthropic for the use of Claude in this case. But Amazon also has invested and partnered with Anthropic to have Claude on their platform to let people use Claude through AWS. So in a sense, this is a continuation of their partnership. And it does, I think, show also that it really is very hard to even try to compete at the frontier model level. Unless you're already a company like Google, Meta, OpenAI, or Anthropic that has a GPT-4-ish level model, it's probably easier to just partner with one of the existing ones rather than build your own version of it.
Yeah, we've even seen a micro version of this with Google, right? I mean, they actually have more computing resources that they can throw at model training than OpenAI and Anthropic, and yet their models, this may change with the next beat, with Gemini 2 and so on, but their models have underperformed relative to certainly OpenAI's models. And that just goes to show you, right, how challenging, how much alpha there still is in kind of model architecture design, optimization schemes and all that, and also just finding out ways to make the hardware kind of sing together really effectively. That's still a challenge. Like it's not trivial. Even a company like Amazon that has tons, and I mean, Amazon at one time at least was like the cluster company. They were the ones who did cloud best, and that's arguably shifted, actually clearly shifted for AI at least. But still, they had that mentality, and now no longer quite being able to stand on their own 2 feet. The partnership with Anthropic makes all the more sense through that lens. And it is something they're using as well to like kind of bolster their own hardware fine-tuning efforts, so they can partner with Anthropic on that. It is also partly a consequence of Anthropic's ROI-oriented culture. So if you know anybody from sorry, I meant Amazon. I don't know if I said Anthropic. Too many A's. Amazon has a very ROI-oriented culture. They always ask themselves, if you know any kind of Amazon alums or people who work there, they're always kind of trying to figure out what is the payoff in the near term. What do customers actually want? So not building towards hypothetical things like AGI so much that they do now have an AGI team, but more like what are the tangible kind of value adds we can create today? And that's been part of what's led them to this position in the AI race where they're sort of seen as falling behind, and I think quite accurately so. So anyway, yeah, Alexa's been a sort of struggling product line for some time, and having a little bit of Anthropic injected in there, might actually help to liven it up a bit. So monthly fee of apparently $5 to $10, by the way, for this new version of Alexa that'll be powered, it seems, by Anthropic.
Right. I like how you just threw in ROI as if everyone knows that means a return on investment. I think you've been in the startup world a bit too long. But yes, Amazon very much is compared to other tech companies, is thrifty in general. So they try to be very oriented on return on investment, as you said. As you might imagine, the paid version of Alexa will offer a bunch of advanced features. You can talk to it as you could to ChatGPT or Claude. You can ask it shopping advice, and apparently it can also fulfill complex queries like ordering food or drafting emails. So it will be interesting to see how many people do opt in. There's some analysis in this article saying that there are approximately 100 million active Alexa users. And so if even 10% of those opt in, that could be hundreds of millions of dollars for Amazon. So yeah, I think this is, this and Siri are both going to be interesting demonstrations of whether everyone wants to have, the smart chatbot functionality in their assistant, or if people don't need it that much. And on to our only lightning round story, because we really are keeping this section short.
It's one way to do quick lightning rounds, I guess.
Yeah. This one is about MiniMax, a new realistic AI video generator. So this is another one coming from China. And this was backed by Alibaba and Tencent. So those are huge, players in the space of AI over at China. And so we got a demo and a trailer showing various AI generation tools. Not clear it's quite up to par with the latest generation of Runway Gen 3, Dream Machine, Kling. This is, after all, coming from a startup, so not hard to get to that level, but still another new model that is pretty impressive when you do look at the videos. And as with the last video posted to YouTube, I will try to actually do a bit more editing and include video clips on top of our talking about this.
Yeah, it's sort of interesting. And they are a startup. They're valued now at more than $2 billion, apparently. So Alibaba did lead a funding round for MiniMax, this company, back in March with a $2 billion valuation. So these young startups really are, in the generative AI era, kind of taking on these crazy valuations. The videos, you're right, like so they describe a testing procedure that they went through in the article to kind of play test it. It does seem like it's maybe a little lackluster. Up to 6 seconds in video generation length. So, compares sort of unfavorably rather to a bunch of other current industry leaders that could do 10%. The resolution's pretty good, 1280 by 720. So, reasonably good stuff, but these are short videos. So yeah, I mean, it's got one of the differentiators apparently that it has is it does seem to have captured generating human movement well. So it does well with hands. It does well with walking and things like that. So that's, kind of interesting. But even within China, right, you've got so many different competitors who are putting out text to video that it's like, I don't know, it's already looking like a crowded market. It seems like all of a sudden this just kind of came out of nowhere. But MiniMax is interesting as a company itself. It is one of China's AI tigers. So these sort of famous companies that are unicorns that are building generative AI products. Zhipu, by the way, which we talk about a lot on the podcast, is among those as well. So there you have it. We'll see. I think it's touted as the first foray, the MiniMax's first foray into this space. So presumably we'll see the quality go up over time as well.
Now into applications and business, and we've got maybe the biggest story of a week, at least as far as just exciting news. The story is that Ilya Sutskever's startup, Safe Superintelligence, or SSI, has raised $1 billion. And that's pretty much the extent of the story as far as we know. So for some context, to recap, Surskever was one of the founders, I believe, at OpenAI, was their chief scientist, just a hugely important figure in the recent history of AI in general. And so ever since the big drama over at OpenAI last year, when Sam Altman was briefly kicked out, Surskever, let's say, took the wrong side on that, you could say, and wound up leaving OpenAI. After a little while, it was announced that he will be funding this startup, creating the startup Safe Superintelligence with some co-founders, including Daniel Gross. And I think it was maybe a few weeks or it's been a little bit of time, but now we have this upcoming news. The only additional bit of news about SSI since the announcement, which is that they have raised $1 billion from a bunch of big name tech investors, A16Z, Sequoia, and the firm that Daniel Gross, one of the CEO of SSI, also a big investor and part of the group that is funding this company.
Yeah, I mean, this is a really interesting fundraise for a lot of reasons. We do also know, reportedly, the valuation. Supposedly, it's a $5 billion valuation, have not gotten sort of formal confirmation. This is one of those situations where they tell you people familiar with the deal said. So it seems like $1 billion on $5 billion is the raise. Investors are really impressive. The fact that so there's so much interesting stuff going on here. There's some inside baseball regarding like Y Combinator even. This is a competitor to OpenAI, right? Very clearly, this company is trying to achieve the same thing OpenAI is trying to achieve, maybe in a different way, maybe with more emphasis on safety, but certainly that's the play here. Daniel Gross is a former partner at Y Combinator. Actually, he was one of the people who interviewed me when I went in to apply to YC back in the day. And so he worked closely with Sam Altman back when Sam Altman was president of Y Combinator. Now Sam is off, obviously the CEO of OpenAI. So there's a lot of like YC kind of in the background relationships here. And Daniel Gross famously headed up AI at Apple for a period of time. So,
and if you don't know, YC, Y Combinator, is a big deal in Silicon Valley for startups. They're a startup incubator. A lot of the like biggest names in tech, as far as newish companies, have come out from Y Combinator over the last decade.
Yeah, and actually recently as well, they've taken a position on a bunch of like AI safety legislation, right? We talked about SB 1047. They came out against that. And so anyway, it's sort of a real kind of incestuous universe of everybody's got some kind of Y Combinator association in this space. Sort of funny to see. There's some open questions about what the strategy is actually going to be here. $1 billion sounds like a lot of money. It is. But when you're talking about competing with companies like OpenAI, companies like Microsoft, the next generation of clusters is going to cost $125 billion to throw down, right? These are the 2027, 2028 era clusters. Raising $1 billion is not enough. If you are going to follow the same path that OpenAI is going to follow, it's simply not enough. We talked about this before, when Safe Superintelligence was first announced. One of the questions that we raised here, right, was what's the differentiator? Like, how are these guys going to compete with the giant ball of capital that is Microsoft, OpenAI, or Google in a context where capital is what you need to buy the outrageous levels of scale that you need to pull off these training runs? Some way, somehow, Ilya has got to come up with a strategy that allows him to do scaling better than OpenAI, that allows him to maybe bypass the need for scaling, or more realistically, as he puts it, kind of scale something that's different. Because there's this question of what are you scaling, right? As you train, for example, a language model, you're training them at ridiculous scale to be incredibly good at doing, well, text autocomplete, really, auto-regressive language modeling, right? And so he's dropping some hints that we don't really know, but it seems like what he's suggesting is, we're rethinking what we're optimizing for. We're rethinking how we're training the model. There's something more than just kind of vanilla scale it to blazes strategy going on here. Beyond that, very, very kind of thin on the details. It's clear they want to emphasize recruitment very heavily. Like there's really a lot of emphasis on culture and all that, but we don't know what the nuts and bolts are, the meat and potatoes. there is one last detail here, which is that Safe Superintelligence is going to be split between Palo Alto in obviously California and Tel Aviv in Israel. And that kind of is interesting in its own right. Maybe it's a recruitment play. There is a lot of great talent in Israel. There's also questions, maybe it's a bit of a hedge against potential AI regulation in any single jurisdiction. Really hard to know, but that just is an unusual and I think fairly noteworthy aspect of this. So we may learn more about the deal, we may not, but $1 billion right now does not seem like enough. If you're just going to go the traditional scaling route, you're competing with real monsters who are going to try to, build these $100 billion, $200 billion, $500 billion clusters. You got to be able to compete somehow with that. So presumably the competition is going to come from what's between Ilya's ears, and he needs to have some good ideas.
Yeah, I think I had exactly the same reaction to this in terms of 1 billion is a lot until you realize that to just get the hardware, not even do the training, would cost a lot more than that. And it's not like you can just rent out the hardware to run a training run that costs hundreds of millions of dollars. I'm pretty sure even if you have the money, if you don't have the GPUs by yourself, you're not going to be able to do that sort of training run. It's just not possible. So it would seem to me that they would have to, build upon something like Llama 3, because you have to have a model trained on all this data. Even if you try to do something clever and smart from a research perspective, there's no getting around scaling and the need for scale. So it'll be very intriguing to see for sure if they do find a way to utilize this amount of money to somehow make a lot of progress without, using the recipe that has been the key to progress basically for the history of OpenAI, right?
Yeah, which Ilya himself, right, was one of the biggest advocates of scaling early on. So it's kind of, almost ironic to see this script flip a little bit.
Yeah, 1 billion, it's just not enough.
It's not, inflation's been really bad. You can't.
On to the next story. This one is on OpenAI and is pretty significant. It is that TSMC has their new upcoming A16 process, which will be for, the next generation of chips for the tiniest of tiny transistors. And OpenAI has reportedly secured capacity for it, indicating that they might be getting into wanting to produce hardware. And that's about the details we have here. The 16 process is still in early stages. The mass production is expected to begin later in the year or two. To me, Jeremie, you presumably have more background on this. My reaction to this was, wait, is OpenAI planning to manufacture hardware of their own? Is that what this is saying? Because that is kind of a big deal.
No, you're totally right. And in fact, it's even crazier than that. Apparently, at first, according to industry sources, so we don't know who this is, but apparently OpenAI at first had actually been talking to TSMC about building a dedicated fab. So just to kind of give a little context, companies like NVIDIA, they design GPUs, right? But then they have to ship those designs off to companies like TSMC to actually fabricate them. And the fabrication process is arguably the single most technologically involved thing that human beings on planet Earth have figured out how to do, right? It's this whole thing about being able to to write chips with 7, 5, and 3 nanometer resolution. It's a ridiculously hard thing to do. These fabs are fucking hard to build. All right. For context, if you want to build a new semiconductor fab, you need to put down an aircraft carrier worth of risk capital. We're talking like $50 billion. That's risk capital. What does that mean? It means you're not guaranteed to even get worthwhile outputs at the end of the day. You could spend $50 billion and basically lose it all. Right. So incredibly hard to do. TSMC has had trouble kind of setting up fabs in North America. You better believe, they're based in Taiwan. They want to get fabrication capacity off Taiwan in the event that China invades, but it's just really hard to do. It is that difficult. There's an old famous sort of story that I think this is about Intel back in the day when they were kind of leading on a lot of fab stuff. When they would build a new fab, they would try to replicate down to the last detail every detail of the construction of the old fabs that were actually working because no one knew why they worked. It's like a fab is like a machine with 500 dials on it. And nobody knows exactly. through trial and error, kind of get a million PhDs who are incredibly well paid to try to tune those dials, right? So what they would do is they would do literally, they would paint the bathrooms the same color because nobody had a clue, like maybe this is the detail that makes the difference. It's so finicky. So the idea that OpenAI was even considering building a dedicated fab is insane. That is like, that should leap out to you as like, wow, holy shit. This is a really like that's an ambitious company. They now seem to be stepping back from that. They're saying, okay, we're not going to try to like build a freaking fab ourselves. Instead of being the next TSMC, we're going to be the next NVIDIA maybe. What we're going to do is we're going to partner with companies like Broadcom and Marvell. So these are companies, you can think of them kind of like NVIDIA. So NVIDIA designs GPUs, but Broadcom and Marvell, they also design chips. They design the custom ASICs or like basically these more kind of application specific like kind of integrated circuits. So these are more use case tailored chips. You can think, for example, as an example of an ASIC, you can think of Google's TPU, right? So that is a custom chip specifically for training, large deep learning models, right? That is what it's about. So OpenAI essentially is trying to make their own TPU. That's one way you can think about this story. That's a big, big deal. Like this is a massive, massive investment of time and energy. They got to do this. They're going to be doing this, it looks like, on this A16 process. So this is where it's a 16 angstrom process. So right now with the 16 angstroms, it's like 1.6 nanometers. So right now we're at 3 nanometers. And so the next couple beats, we're going to get 2 nanometers, and then we'll eventually get down to the 1.6 nanometers. And that'll be this. So it's a couple beats away. But essentially, they're partnering with Broadcom and Marvell to set this up. It's an incredibly capital intensive project. And really what this is it's a really interesting strategic partnership too. Right now, Broadcom and Marvell, because they design ASICs, right? They don't design GPUs. They're not directly competing with NVIDIA. But through a partnership like this, OpenAI is basically asking them to design chips that would compete with NVIDIA GPUs. And that is pushing Broadcom and Marvell into closer competition with NVIDIA. So it's a really, really interesting play, and it has all kinds of implications for the industry of chip design itself. So I think this is a story we're definitely going to be hearing more about as it unfolds. But this node, the A16 node, is going to be a very, very loaded node from the standpoint of competition on chip design.
Yes, and the note on TPUs, I think, is worth highlighting, where Broadcom was at least a big part of how Google came to develop DPU, and the TPU is the tensor processing unit, so it's like not as general purpose as a GPU, right? Tensor processing units are for AI, and they are presumably, more efficient, more powerful. If you make your ASIC is essentially sort of a customized chip that's less general purpose. So one of the big advantages that Google has over competitors is that they have been working on DPUs since, I think the first one was 2015. Now they're in their 5th or 6th generation. So designing such a chip is not easy. Broadcom has shown that they can do it, and they are, raking in billions of dollars because of our partnership with Google. Google actually wants to move away and be able to do it themselves. But we've seen that precedent, and it would be interesting to see if OpenAI is able to essentially replicate what Google has done with their own custom hardware, which would then kind of shift the playing space in several ways. For instance, reliance on external compute, on Azure from Microsoft. OpenAI, I would imagine, still can't do their own training runs in-house, so to speak. So having your own custom chips, it's all very intriguing in a very nerdy kind of way. On to the lightning round, and the first story is again on OpenAI. It is that OpenAI is weighing changes to its corporate structure amid latest funding talks. So as we've noted, I believe last week or 2 weeks ago, OpenAI is looking to raise more money. They're looking to be valued at over $100 billion. They have some big names like Apple and NVIDIA talking to participate in this round alongside Microsoft and existing investors. If this would be successful, that would make OpenAI one of the most valuable technology startups in Silicon Valley history. That would be like above Stripe, which raised a $95 billion valuation while doing private fundraising. So yeah, add to that kind of price, $100 billion valuation. Wouldn't be surprised if investors are hoping for a slightly less weird corporate structure.
Yeah, it's also, we always knew that we were going to be here in some sense. This is another one of these things where, people find themselves asking questions about the level of sincerity with which OpenAI had been approaching this whole corporate structure from the very beginning, or at least the extent to which Sam Altman now seems to be deviating OpenAI from the board structure that, it's weird for sure, but they created it for a very explicit reason back in the day. They were concerned about a single company monopolizing the revenues that would come from the success of AGI, right? And so the way it was set up initially was you had this nonprofit entity, this nonprofit board that kind of runs, it owns essentially a for-profit entity like OpenAI, the for-profit entity. And essentially, if you invest in the for-profit entity, your returns are capped. And this is the capped for-profit structure. You could only make, I think it was 100-fold, 100x return. So when Microsoft, for example, put their big investment in back in the day, I think it was $10 billion, the most recent one, their returns were capped to 100x the original investment. And the argument here was, if we end up making more than that, then essentially any surplus does not go to Microsoft, so that you don't have a situation where the rich get outrageously richer. Obviously, they make a lot of money, but they're not going to get infinitely more wealthy. Instead, those revenues are redirected, I believe it was to the OpenAI nonprofit parent entity for redistribution in some broader sense, sort of across the population. And there are all kinds of thinking. There was all kinds of thinking that OpenAI people had done, including somebody called Cullen O'Keefe, who put together this proposal for the windfall clause. This idea that if OpenAI at some point, or if a lab that signed onto this clause at some point generates gigantic amount of windfall revenues, then they commit in advance to sharing that, to redistributing it according to a certain scheme. And so all of this was factored in, was baked into that board structure. And now, the whole idea was for precisely this eventuality, when you see the valuation of the company soaring like crazy, now all of a sudden, whoops, we're just saying, okay, forget about that. We're going to change the corporate structure. So you can read into that what you will. It certainly is consistent with the strong incentives, as you said, Andrey, that must exist. You have all these companies that want to see returns, right? It's no good if there's a cap on these returns. Apparently, there hasn't been a final decision on whether or not to change the structure in that direction, but it is under consideration to remove this cap on profits, right? That cap for profit structure, that's apparently what's potentially on the chopping block, though nothing's finalized. And this is a space where you just have a lot of these weird structures. Obviously, Anthropic has a more traditional benefit corporation structure, but it's sort of to make sure that their fiduciary obligation is not to the shareholders, but rather to the wider population. And so anyway, the public benefit, that is. We'll see if this actually ends up changing. If it does, don't be surprised to see a lot of people complaining that this might kind of go against the grain of OpenAI's initial commitments.
Next story is going back to a trend we've seen more and more. It's about Amazon hiring the founders of another startup. This time, the startup is Covariant. So Covariant is an AI robotics startup that's been working on essentially advanced robotics for manufacturing, for kind of industrial use cases, fulfillment, things like that. They've been around since 2017, co-founded by Peter Beal, notably a major professor, an AI researcher, also Peter Chen and Rocky Druan. All of those co-founders are now going to Amazon along with a quarter of the startup's employees. So very much similar to what we've seen with Character.ai and Google, what we saw with Amazon and Adept back in June. This is like the fifth or sixth example of this weird sort of acqui-hire, but not actually acquire deal. So it's certainly an interesting thing to see. And I think is an indicator also that in this space of advanced robotics for manufacturing fulfillment, that's been around for quite a while now. Covariant has been around since 2017. What I've kind of heard and seen a little bit is that the companies are struggling to make it work and to really scale. Covariant has said that they have like a robotics foundation model. They have advanced AI, but somehow this move does hint to me that maybe it's challenging to really kind of push in and make it a successful business, at least so far.
Yeah, totally. It's also it's a super weird deal, right? Like these, there's sometimes called reverse acqui-hires, where you just scoop up, you hollow out the company basically, and let the shell sort of float out into the ether. And in this case, to be honest, I mean, like I don't know how morale's going to be at Covariant rather, following this pseudo acquisition. I mean, you're gutting the entire C-suite. You're basically having these folks abandon ship. Implicitly, what the C-suite is saying when they leave for Amazon is, I think I have more potential over there. And now they've got the COO stepping into the CEO role, and that comes with a whole bunch of challenges for a company, especially one that's been around for a while. And anyway, so this is kind of, it's dicey. I don't know how long Covariant is going to continue to be a going proposition after something like this. It sort of makes you think of other acquisitions like this that you referred to earlier. And it is being done as well to avoid regulatory scrutiny, right? Antitrust scrutiny, or this idea of like consolidating all the companies in the space. So acquiring companies like Amazon in this instance, presumably are trying to avoid an all-out acquisition because of the optics of it. But yeah, we'll see it. We'll see if it actually plays out that way for them.
Right. And one more note on this deal, in addition to hiring a lot of the people from Covariant, there's also been a deal signed for a non-exclusive license to use Covariant's AI models within Amazon. So again, something we saw with Character.ai and Google and some other examples. So this is, I think, partially like getting your employees. On the other hand, it's also kind of a partnership deal. So I don't know if morale is, maybe this is good for Covariant because now it's hard to say, but certainly, it's not been the case that these kinds of deals were common in tech until like this year.
Yeah, I suspect that the licensing component, to the extent that it looks like a partnership, to me that smells more like, hey, regulators, like we're actually in this together. We're taking a shared risk on this venture. There's no like
We're not buying the technology.
Yeah, that's right. Not... Yeah. Who knows? But yeah.
Alrighty, next up, Chinese GPU maker XCT, once valued at 2.1 billion, is on the verge of collapse, and shareholders are now suing the founder. So this is the Xiangxian Computing Technology Group that apparently was once considered China's NVIDIA, is now facing potential collapse. They have produced 2 desktop and 1 workstation GPU models. They are still seemingly financially not meeting expectations, are under a lot of pressure. And their founder, Tang Jimin, is now being sued for failing to raise over $70 billion in Series B financing.
I think this is a good time to come out and say I have also failed to raise $70 billion in Series B financing.
But you never promised it. So
that's true. Okay, that's fair. I hereby do not promise to do that. So this is really interesting. It's a symptom of a wider problem as well in the Chinese sort of semiconductor design and fabrication space, where corruption is like crazy rampant. They just like light billions and billions of dollars on fire on a regular basis, which can sound stupid unless you factor in the fact that it is a national security priority for China to kind of get ahead in the AI race. So they're really willing to just light that money on fire, and it's led to some wins. But anyway, so this is one of those cases where that's, it does cost you money every once in a while. The corruption in this seems to have taken the form of the founder basically taking the money some senior executives, I should say, just taking the money, like pocketing proceeds from the fundraise, not actually spending it on R&D, but just like, kind of taking it for themselves, which is, by the way, not legal. So anyway, that's it. One of the big challenges that they've faced is poor yields. And this has been an issue consistently for Chinese companies. Anytime you see a big headline where it's like, some Chinese company just came out with a new GPU and it looks really, really good. And there's a teardown and, it does look solid. Always ask yourself in the background, what is the actual yield, though, of the process that is being used to fabricate this device? Very often in China, what you find is the yields are just garbage. And so it's just not economically viable without state support. And they do have state support that's subsidizing these industries. So just kind of a background thing here. And I think the corruption note, we haven't talked a lot about these high profile kind of corruption crashes, if you can call them that, in the Chinese semiconductor space. But they do happen, and they happen quite a bit. So another interesting instance of that.
And the last story for the section, TSMC aims to ready next-gen silicon photonics for AI in 5 years. So these silicon photonics chips have been growing in demand, and that's primarily for high data rate modules to increase fiber optic network capacity. So you want to communicate between GPUs very rapidly. That's one of the essential components in these giant AI clusters. This, obviously, I don't know as much about this as you, but the gist from the article is that these are still not being developed at scale. These kinds of silicon photonic technologies, there's a lot of push behind it since it will help with these AI clusters. So TSMC has stated that they are ramping up on the ability to do these kinds of chips over the next few years.
Yeah, there are a lot of advantages. So right now, people use basically like fine electric wires and cables and stuff to pass data around among and between and within GPUs. Usually between data centers, you're going with fiber optics actually, but within GPUs and within data centers, usually it's those wires, and they tend to be a lot worse at, for example, energy efficiency. So they'll be much less energy efficient than getting just optical interconnects, which is what this is all about. It's widely viewed that optical interconnects are going to be kind of the wave of the future over the next 5 years or so. And specifically this area of co-packaged optics, where you're bringing the optical interconnects as close to the chip as you can, by which I mean you want to essentially have all your GPUs connected by optical interconnects. And then when you start to get on the chip, as much as possible, you even get those wires replaced with optical interconnects. So it's essentially just a way to make everything work more efficiently and faster. You benefit from the fact that light just moves crazy fast, and it doesn't tend to burn energy, create heat as it moves around in the same way that electrons do as they kind of bump into each other in a circuit. Right now, the issue is there are already some of these deployments, some of these co-packaged optics deployments out there, but they're at really low volumes, like you said. And the big challenge is, how do you get the industry to invest enough in this technology that it will come online in 5 years? There's just so much R&D required to do this. And so you're seeing the emergence of a kind of industry alliance that's effectively subsidizing this process of bringing this new technology online. May not be profitable, may not be beneficial in the short term, but unless they make this upfront investment, they're never going to get there. And so you see quite a bit of coordination. You've got Meta and Microsoft, for example, backing this co-packaged optics technology, and a bunch of others stepping in the space. Not unlike what you see with Apple and TSMC. There's a relationship there where Apple will usually order from TSMC's most advanced node, their highest resolution, tiniest node, for their iPhone. And effectively, they're subsidizing TSMC's research and development on that latest node. And then, we get to benefit, other companies rather get to benefit from it later on as it becomes a more mature node. This is basically what's happening at the industry level with co-packaged optics. So interesting space. And I think more and more going to be relevant at the chip design and fabrication level in the next 5 years or so.
And onto projects and open source, where we have only one story, and it is about Alibaba and their latest open model release, Qwen2-VL. So VL there is standing for vision language, I assume, because this release is aiming to enhance visual understanding, video comprehension, and multilingual text-image processing. This release is coming in 3 variants, as we often have seen with these kinds of models. There's a 72 billion parameter model that's on the high range of model size. Pretty much the only larger model. Well, there's a couple, but aside from Meta 400B, 70 billion is sort of that category of where most of the big open source language models are. There's also 7 billion and 2 billion parameter models, and those are being released under a fully permissive Apache 2.0 license. The 72 billion parameter model is not being released. You don't have access to weights. You will most likely have to use it through the Alibaba Cloud API. They have released some benchmark numbers, and they're quite impressive. The 7 billion parameter model does beat GPT-4o Mini on some reasoning and vision task. In particular, on video, it performs quite well and better than any or almost any other open source model of a similar size. So yeah, we sometimes, I think, can get tired of like, oh, another model that's like, how many of these do we have? But as a vision language model, I think in that category, we don't have quite as many things. Llama, of course, is primarily just language. So this could be a big deal.
Yeah, and especially interesting, I think you mentioned it's on an Apache license, which is distinct from what we've seen from other big releases from companies like Chirpu that put out, these special licenses that say, famously, if there is a disagreement that needs to be adjudicated with respect to the use of this model, it'll get adjudicated in the Chinese legal system. It kind of binds the end user to Chinese law, which is an interesting way of waging a sort of open source lawfare, or not lawfare, but open source warfare in a certain kind of informal sense. And not doing that here. We're getting just the vanilla Apache 2.0 license. So this is a true open source play. There's a bunch of interesting kind of innovations going on here. They have this thing they called naive dynamic resolution support. Basically, this allows the model to take in images at all resolutions, and it dynamically maps them to a number of tokens. So anyway, it's sort of like more robust in that sense to different image shapes and sizes. And then another one, which I thought was really interesting, this idea of what they call multimodal rotary position embedding MROPE, which is, so there is this notion of rope, like rotary position embedding that's been done for a long time. It's a little complicated to explain, but basically like you add a signal, you overlay a signal on top of your input tokens that the model can learn to interpret as giving away the position of that token in the input. So transformers natively can't actually tell what order tokens are appearing in, and they don't care about it. What you need to do is give the transformer a hint by overlaying some kind of signal onto the embeddings that you feed it. Well, what they're doing here is the same thing, except they're overlaying 3 different of these signals at the same time. One for the sort of x-axis, x dimension of these images, one for the y dimension, and one for the time dimension. And combining those together, that kind of allows the model to tell, okay, which of these tokens correspond to which patch of the image and what time slice of this video. So it allows you to kind of generalize the idea of the more standard rotary position embedding. So I thought that was kind of cool. And it does seem, as you said, to lead to really impressive results. So there you go, Qwen2VL.
Moving on to the research and advancement section, and we start with a research paper that I'm sure, Jeremie, you found very interesting. The title of the paper is Fireflyer AI-HPC, a cost-effective software hardware co-design for deep learning. This is coming from DeepSeek AI, who we've seen release some powerful models, I think in particular for coding in the past. And so this paper kind of describes in some detail their architecture, their system that they developed for training. And so they go into how they deployed this Fireflyer 2 system with 10,000 PCIe A100 GPUs. They say that they are able to achieve or approximate a performance of, let's say, more powerful product from NVIDIA, while reducing cost and energy consumption. And after that, there's a bunch of nerdy details about how they did that. So it sounds like they worked on some communication technology. Honestly, not my expertise. So I'll just let Jeremie take over and give your thoughts.
honestly, I think you've highlighted the most relevant pieces there. It is an engineering paper, so it gets in the weeds. There are just a couple things that I thought were kind of like these little nuggets that were worth surfacing, because I think listeners will be interested. But the bulk of the paper is, as you said, it's a schlep, right? It's just a high detail thing. What they do is they basically take this cluster of A100 GPUs that they have, like you said, these 10,000 A100s, PCIe GPUs. So you can think of these like individual GPUs. And then if you've got these individual GPUs, you have to figure out how to like wire them together in pods, and then wire the pods together and create like a functioning cluster that unifies all their work and gets them to dance together in a coherent way. And what they do is they essentially set that up. They walk you through the process of how they achieve that. And they reduce costs by half and energy consumption by 40% using their fancy techniques. What I want to emphasize, though, is just a plot that's like that's in the paper. It's figure 2 here. And it's so interesting. It shows you how over time, different components of GPUs, different computing components, different elements of the GPU, different features of the GPU have been getting better over time. So when you think about computing and creating these clusters for very scaled compute runs, people often think about what's known as the logic. So the number of operations that a GPU can perform, the number of flops, floating point operations that a GPU can perform. That matters a lot. But it turns out that the number of flops that GPUs can perform, their efficiency, has been increasing about, roughly speaking, it's like 3x year over year. So every year you get 3 times better flops. But that's not the only number that matters. So you can number crunch like crazy, but what happens in practice when you're training a large model is you have to split up your model, send bits of it to different GPUs. They have to compute the gradients, basically the model weight updates that they're going to sort of recommend, if you will. And then you have to pool all those weight updates together. And then you have to redistribute the new model weights to all those GPUs so that all the GPUs are kind of updating the same consistent model, so you can get it to converge. And that requires a ridiculous amount of bandwidth. You got to be sending model and parameters and data left, right, and center to all these GPUs. So interconnect bandwidth between different kind of GPUs becomes really important, and so does the on-GPU high bandwidth memory. And so these two things, the interconnect bandwidth and the on-GPU high bandwidth memory, have been scaling much, much more slowly than the flops, than the logic component on these GPUs. And the consequence of that is that we are very quickly going to find, in fact, we are already getting there, that we're not flops bounded, we are bandwidth bounded. We're essentially like high bandwidth memory and interconnect bandwidth. So in other words, within and among GPUs, the memory bandwidth required to move these weights around, to move activations around, gradient updates around, is our ability to do that fast is not growing fast enough to keep up with the other, with the logic, say, and the wider demand for computing. And so we're hitting that wall right now, the sort of memory wall. And this is just something to look out for. So just trying to kind of increase the level of resolution at which we're thinking about GPUs. It's not just about, can we get more logic on this chip? Can we get more flops? But you can't use those flops if you can't transmit data between your GPUs fast enough to get, the information you need to run those computations in the first place to that GPU. So anyway, I thought it was a really interesting paper for the reason of that figure alone, if nothing else. For context, 3x year over year increase in logic and flops, 1.6x increase year over year, 1.4x increase year over year only in the sort of like high bandwidth memory and interconnect bandwidth. So much slower rate of progress on that exponential curve. So I thought it was kind of interesting, a little bit more resolution on Moore's law, if you will.
Yeah, I think it is interesting. And it does highlight something that I guess as someone not technical, someone outside AI, it may not be apparent, which is at these companies, at something like Anthropic, OpenAI, some of the most complex technical challenges are really to do with this kind of thing, with the infrastructure, with the training cluster, with scaling. Like, it's not algorithmic. It's not, there are some details related to like how to train an optimal language model for sure. and how you set up a training run. But, I think a lot of it is hardware and how to make the hardware work. And
100%.
Yeah.
Yeah. It's at the end of the day, the way to think of it is like, it's all about training efficiency, right? Like you want a crap ton of compute, and then you want to point that compute in the direction that makes it most efficiently useful for creating intelligence. And you can think of model architecture design and optimizer design and of that kind of engineering as one way to kind of squeeze more juice out of the lemon. But you can also just make a bigger lemon, have more computing power, or just optimize that computing power. So you're right. It's like, it is all kind of one problem. And that is a reason why structurally companies like Google are massively advantaged, because they own the whole stack and they can optimize the whole stack together. That's also why, right, earlier today, we talked about OpenAI trying to design their own chips. That's why they're trying to do it. They want to own more of the stack so they can customize things. They're thinking of it as a holistic problem, right? Just how do I, get more compute efficiency out of my system?
And on to the second story. This is actually a blog post titled 100 million token context windows. And this is coming from the company Magic. It came alongside an announcement that they've raised $465 million. So, it's a bit of a mix of research and PR, I will say. This blog post pretty much goes into how we've covered on and off this topic of long context reasoning, which is to say you have a big chunk of input, let's say 10 books, and you want your model to be able to take in this large amount of text and actually reason about it. So this has been one of the challenges in AI and in scaling language models is if you give it, 100,000 words, can it actually use the content of 100,000 words effectively, even if technically you can? And the claim being made in a blog post is, one, that the current benchmarks are flawed, which I think is generally accepted. This needle in a haystack test that is often used is pretty much saying, can you pick out this one tiny bit of text that has been inserted into this longer document, and the inserted bit does stand out as something that doesn't really belong there. So that has been an issue with a benchmark. We've seen some efforts on that front. And here they introduced kind of another way to evaluate it with essentially kind of randomized data where there's no needle that stands out. It's just randomized pairs of things where you really do need to sort of have a very effective memory to be able to complete the problem. They then say that they have a new technique that works really, really, really well on it. And that's it. I didn't see anything about how it actually works, which was very disappointing, but that's their claim.
Yeah, it kind of feels like that is very much just the norm now, right? We're not even getting those. You remember the days of like technical reports when people would go, oh, it's not a paper, but at least it's a technical report, and they'd complain about that. Well, now we're not even getting that, right? Increasingly, we're just getting the like raw computational inputs. If we're lucky and we beg enough, we'll find out how many H100s they use to train this thing. But beyond that, like, you're not going to get a lot of detail. So that is very much this paper. I did like this whole discussion that you were pointing at with the needle in a haystack stuff, right? So they created this new, essentially eval called hash hop. And so there's this idea of hashes, right? And these are kind of like random strings of characters and numbers and letters. And the point of them is that they are random. In other words, like so imagine a document where you just have a bunch of hashes, a bunch of random digits and letters, separate, a space between them, and then another chunk and another chunk like that. And now in that context, right, you're asked to recall one of these random hashes. What this forces the model to do is to actually kind of genuinely keep in mind the whole document that it's just read. If it's going to correctly pick out a random hash from a document filled with other random hashes, it can't use cheat codes. It can't just, for example, famously when Anthropic ran their big needle in a haystack test, I don't know what they fed it, but it was something like they feed the collective works of Shakespeare, and somewhere in between they include like a pizza recipe, right? And that sticks out like a sore thumb. And so the model quite quickly goes, oh, wow, that's obviously not supposed to be here. And it makes it really easy. It doesn't, if you were asked to pick out the thing that doesn't belong in a document, you wouldn't actually have to read the document super attentively, right? You could just skim and wait until you see something that's like, what the hell is a pizza recipe? Okay, clearly this is the thing. So that creates an artificial sense of an inflated sense of the model's actual capacity on these evals. Whereas if you have completely random strings, a sort of hash in this case, then maybe you're able to force the model to keep the whole thing in mind, and as it kind of looks for one. And it does this thing where they also force it to do these sort of logic hops. This is why it's called hash hop. So they will map one hash to another hash. They'll say like, this hash connects to this hash, and that hash connects to this next hash, and so on, like a string of connected hashes. And so they can go and basically say, okay, model, I want you to tell me what the hash that is connected to this hash is based on the giant document you were given. And they can even ask it for, okay, what is the fifth hash that is connected to this one? So force the model to go through like many steps of recall. And that starts to look more like the kind of reasoning that humans do when they read long documents, right? You're kind of integrating information from across a document and you're reasoning on top of it. And so I thought this was really interesting. I wouldn't be surprised if we start to see this happen a lot more. What they're doing is functionally they're measuring the emergence of what are known as induction heads, which are actually in mechanistic interpretability, these structures that have been fairly recently discovered in language models that essentially will look back over the sequence that's been fed to them for previous instances of the current token. Basically see like if the current token is pizza, you look back over the previous sequence and go, every time I've seen pizza previously, what was the word that followed that? And you grab that word and then you predict that that's the next word. These are known as induction heads. They're actually hypothesized to be the main driver of the incredible meta-learning ability of language models. And there's a fascinating bit of literature on how they emerge, and every training curve actually that you'll see will feature a little induction head bump, as it's called, a little bump where the model suddenly learns about the induction head and you'll see the loss drop suddenly. So anyway, it's a really, really interesting way to probe at this very fundamental and important contributor to meta learning. And so I thought great paper, but again, doesn't really tell us much about what the hell is going on under the hood.
Yeah, I think calling it a paper is a bit generous.
Yeah, great post.
It's a good blog post. And I will say, to this level of detail, I find myself being a little skeptical, but this is actually a good benchmark in the sense that, okay, you've taken out the bit where it stands out like a sore thumb, but you've now changed it to just looking at hashes, which is totally random. Like, it's not modeling anything the model would need to do in practice, right? So
I think in combination with the needle in a haystack test, I think it would be interesting, right? Because it's probing at the thing that needle in a haystack is missing, but what it doesn't have is the semantics of language that needle in a haystack does capture.
Yeah, so you can make a case for it, but they set up their own benchmark and then they say they trained this LTM mini 100 million token context model. 100 million tokens for context is about 750 novels. And so the details we have here is for each decoded token, LTM2 mini sequence dimension algorithm is roughly 1,000 times cheaper than Llama 3.145B. So I from reading this, I don't know if this is a model that's 100 billion or it's an algorithm that's able to do 100 million.
I love 2024.
That's different. So anyway, exciting progress on long context reasoning, maybe. And congrats to Magic for raising a bunch of money and training their own models. Alrighty, on to lightning round. The first story is smaller, weaker, yet better, training LLM reasoners via compute optimal sampling. So there is a trade-off between using a stronger but expensive model or a weaker but cheaper model when you generate synthetic data for training, right? You can generate more data with a weaker model, or you can use a stronger model to generate better data potentially, but not as much data. And so that's the topic of the paper, this kind of problem of compute optimal sampling. And they show that depending on the different settings, knowledge distillation, self-improvement, you can find the right balance, so to speak. and actually get a lot more out of weaker models and not just the stronger ones.
Yeah, I thought this was one of those, again, I'm fond of talking about the kind of simple papers that make you go, oh, wait, why wasn't this done before? And it does seem obvious in retrospect, but I think it is an important result because people tend to default to just like saying, hey, I'm generating synthetic data from my model. I'm going to use the best model I can find, like, GPT-4 Turbo or whatever it is, or Claude 3.5 Sonnet to generate text that my model will then learn from. And it's an interesting paper. The results vary, but they do suggest that you often benefit from saying, hey, actually, instead of having really, really high quality text, but a small amount of it, you're better off having kind of more medium quality text, but a large amount of it. I wouldn't be surprised if the capacity of the student model is actually a big factor here. In other words, the capacity of the model that you're training using data that you generated from the sort of GPT-4 model or whatever you choose. Because if you have a really small student model, it might not even be able to learn all of the subtleties that make a really exquisite model that much better. So it's kind of a waste of time out of the gate. It's sort of like trying to teach math to a 5-year-old, right? You're better off with more examples of simple math problems than a small number of like rigorously correct and complex examples. So yeah, I wonder if that's kind of part of this, and that's something that I didn't see addressed directly in the paper, like the capacity of the student model as a function of all this, but be curious to see that looked at too.
And on to the last story. It's about AnyGraph, an effective and efficient graph foundation model. So graph learning in AI and deep learning, you have graph neural nets, so-called, and they specialize in graphs. Graphs are different from other modalities. You have a node, you can think of it as like a dot, there's another dot, and they're connected by a line, and you have this complex network. That's what a graph is. And because of this sort of non-uniform structure, typically you need special types of architectures to deal with graphs, and they are generally speaking harder to learn with. And as a result, you don't have as easy a time creating what they call here a foundation model, where a foundation model is basically like, okay, this model can take any text and do something with that text. This model can take any image and do something with the image. That's pretty hard to do with graphs because graphs have different structure. They have different, contents per node. The edges may or may not be directed. They may or may not have features on them. There's a lot of variation that's kind of not exactly there with text or images. And the gist of it is here, the researchers from the University of Hong Kong have introduced what they say is a graph foundation model called AnyGraph, building graph mixtures of experts architecture that can then deal with a big variety of graphs. Because we shouldn't get into the technical details. There's a lot that went into it, but they did evaluate on experiments on 38 diverse graph datasets and showed that without training on any one dataset, you are able to generalize and do well, which is what you want from that foundation model. Okay, and moving on to policy and safety. Our first story is once again about SB 1047, as it has been for the last couple of weeks. And the news this time is that it has been approved by the California Legislature. So we've kind of known this was going to happen, that this was leading to this. But now that it has been approved, it will be soon moving on to Governor Gavin Newsom to be able to veto it or not. And he has not given a stance on the legislation yet. So there's still a potential for a veto here and for it not being passed. The chances are probably that it is going to pass, given that this is kind of a Democratic effort and Gavin Newsom is a Democrat. But it seems more likely than not that this is going to be becoming a law, but still up in the air.
I think I remember, I'm actually just looking it up right now. Interesting. Okay, so there's a prediction market called Polymarket that has people bet on outcomes. Essentially, it's betting odds. Right now, they're posting a 38% chance that Gavin Newsom will sign the bill into law, which is interesting. There has been a lot of active lobbying from all kinds of big tech companies and Y Combinator, as well as we've talked about, trying to push back on this bill. And so, that might be part of this as well. So very hard to tell. There's been a lot of inflated rhetoric in all directions, but including in the direction of sort of, let's say, claiming that the bill does things that it doesn't do. And that's been a recurring issue. So, that all this might be part of the landscape here. And I guess we'll just find out when he actually decides whether or not to sign it. But there does seem to be a surprising amount of uncertainty given the political lines that you've indicated. Like, you would think a Democratic governor, Democratic state legislature, so probably signed into law. It seems a little bit uncertain at this point.
Yes, I should kind of amend that statement. Although on party lines is likely to pass, it's not quite that simple. Gavin Newsom is sort of an ally and has touted AI's economic potential. Obviously, as the governor of California, he's very invested in AI, which has been a huge economic driver over the past couple of years. He would not want to anger that industry. So very much still up in the air. Gavin Newsom has until September 30th to sign or veto the measure. And we'll just have to see. And no doubt we'll talk about whatever happens soon. Next story is now a research paper related to safety, and it is called Tamper-Resistant Safeguards for Open Weight LLMs. So we've mentioned this on and off with open weight models that, in general, you want to make your models hard to jailbreak. You want to make it so they cannot be misused for various reasons. But if you release your model and its weights out into the open, as, for instance, Meta has done, there's really nothing you can do, more or less. Like, once you have access to the weights, you can undo any sort of training for safety. You don't even need to jailbreak it. You can just retrain it, more or less, to do what you want. And so this paper is introducing this TAR method for trying to build some tamper-resistant safeguards so that adversaries cannot remove the safeguards even after training for a fairly large amount of time. And they say that in evaluation and red teaming analysis, they found that the method is effective and also preserves capabilities, which is another more important dimension of this. So that's the gist, and now I'll let Jeremie dive into the details, as I'm sure you love to do.
Yeah. Well, thank you. This is, I think, a really interesting paper for the reason you highlighted. So much concern over open source models. Like, if these models get to be to the point where they're, GPT-5, GPT-6 quality, and they're open source, and they can be weaponized, jailbroken, that can be an issue. So what they do here is actually quite interesting. So we can think back to the good old days of generative adversarial networks, GANs, which used to be the way you would train generative image models back in the day, and sort of have turned into diffusion models nowadays. But so this is kind of following a similar philosophy. They have two stages of training. So they have their language model, and they'll start by baking in some kind of safety measure. So, reinforcement learning from human feedback, or, gradient descent, or strategies that are meant to make the model forget about dangerous knowledge. And so they got that safety measure baked in. And what they'll start to do is this iterative training procedure where in the first iteration, they will have an automated jailbreaking technique, some kind of tampering attack that involves fine-tuning that model to try to get it to unlearn the safeguarded behavior or relearn the dangerous capability. And so, a common way to do this, if you have, for example, an instruction fine-tuned model that's trained to refuse to execute on instructions for, like, helping you to build a bomb or something, would be to give the model some extra training with instruction data where the instructions are dangerous, and it includes the execution of those instructions. So you're kind of training the model to go, okay, never mind, I actually will answer these dangerous queries. So you start with that. You have your base model with your safeguards. You have your phase where you're trying to get it to unlearn those safeguards. And then you're going to try to bake into it a counter essentially to that. So you're going to try to kind of re-bake in the safeguard, but as you do that, there's a risk that the model will forget the actual capabilities that you wanted it to have. And so there's this kind of tension between getting the model to learn the safeguards and unlearn dangerous knowledge, but not unlearn too much of the good capabilities you want it to have. And so there's this outer loop where you actually want to get the model to remember the capabilities, the sort of capability of retention. And anyway, the way they execute this is quite interesting, but it's too much detail to go into here. They find a significant level of success when they compare their method to others, both on the capability of retention side and on the kind of safe behavior side. They're able to retain the safeguards while preventing capabilities from being lost, even if you allow an adversary to try to fine-tune out the safeguards. Now, one important caveat is that this does not work for, let's say, attacks that you didn't factor into your training process. There are a whole bunch of attacks that we haven't yet discovered that we'll discover later. And those attacks will probably, work much better on this kind of model. And the issue there is with open source models, you just kind of put them out there and you can start your clock and eventually somebody's going to come up with an attack that the people who developed the model never thought of. And so this isn't necessarily a good sort of robust forward-looking technique, but it certainly does help on kind of, in a sense, it helps make it a little bit harder for people to jailbreak these models. It isn't terribly effective at a certain category of attack called parameter efficient fine-tuning attacks. This is kind of like LoRa. So if you design attacks that only retrain some of the model parameters, but not all in strategically chosen ways, this technique doesn't tend to work really well. So there are holes, but this is certainly a better technique than we've seen before. It's something that I think, some people might have thought might not have been possible. And so here we have a pretty good update on our ability to secure these open source models. I don't think it lives up quite to the hype that the paper is sort of tees up at the beginning, where they kind of imply that this will herald the new era for open source safeguards. I think it's between incremental and not incremental. It's certainly interesting, and it'll need a lot more robustness in order to be sort of future proof in the way that I think it will need to be.
On to lightning round, and wow, we are making pretty good time. I will
say.
We're
crushing it.
So, let's see how fast we can get through this. Next story, we got some hardware and some China, so very much on track with our usual topics. The story is that China's chip capabilities are just 3 years behind TSMC, according to a teardown. So this is a teardown from a Tokyo-based Technalia, which is a semiconductor research company. And that's the gist of it, is that it does seem like China's chip manufacturing capabilities are catching up somewhat to TSMC. And 3 years may not sound like that much, but given the cycles in the space, 3 years behind means that in a couple of years, China will be able to make cutting edge AI computing infrastructure of the sort that is being made now. So I would not, I guess I don't have a background. I do wonder what the estimate or consensus was, and if this is different as far as you know, Jeremie.
Yeah, I mean, people throw numbers around all the time that, 5 years, 3 years, 1 year, it's very unclear. Some people will index towards looking at what are the actual models coming out of China, right? And along some axes, you're seeing genuinely impressive models. You're not tending to see models that compete with Claude 3.5 Sonnet or whatever. And so anyway, I think there's a lot of room for uncertainty. One of the things that they don't quite get into here that, again, is every time you hear about not just chips from China, but chips from anywhere, always ask yourself the question, yields, right? You can have a really impressive chip that looks really solid. And on the basis of that chip alone, you might be telling yourself, okay, well, China, oh, wow, they must be really close. But if that chip can't be produced at good yields, if 50% of the chips that come off the production line don't work, then effectively the economic yield of that chip is not high or may not be high enough to be sustainable. And that's where you get into things where, like we talked about, Chinese government has to subsidize these things. So in this instance, I think that's part of the subtext here. Essentially what we have is TSMC's 5 nanometer process is being competed with, it seems, quite effectively by HiSilicon's design capabilities at 7 nanometers. So what they're probably doing there is multi-patterning. This is this idea where, yes, you have a crappier, lower resolution process, but if you use it to go over your chip multiple times, you can achieve the same outcome as if you had used that higher resolution 5 nanometer process. But going over the chip multiple times means it's more expensive, your yields go down, and so on and so forth. So a lot of uncertainty still left here. It's just another indication that, yes, in fact, Huawei and their subsidiary HiSilicon that actually does a lot of their chip design stuff they're a live player. You should expect the U.S. export control stuff to start to kick in more and more over time as a layered process, and they're likely to fall behind more and more. But for now, it's further along than I think a lot of people would have expected. The operating question is always yields, and the thing with the PRC, with China, that is that they're willing to subsidize this stuff. So economic yields don't necessarily matter in the same way, let's say.
And the next story is pretty related and kind of builds off of this one. The story is that China is threatening to cut off ASML over new U.S. chip curbs. So that would mean permanently cutting off the Dutch chip toolmaker ASML if the company does implement the latest U.S. export curbs that would prevent ASML from maintaining the DUV, deep ultraviolet lithography machines it has sold to China and selling spare parts, effectively making it impossible for, a very hard part of the thing with ASML, the maker of these incredibly complex machines you need for fabrication of chips. They sell you these lithography machines. They also then have a contract to essentially continually maintain it. And, this is such advanced technology. It's very important to have that. So, unsurprising in a sense that China would want to prevent that. And if they were to cut off the chipmaker ASML, would be very significant since ASML is, as far as I know, kind of the only company producing the cutting edge EUV machines.
Yeah, exactly. And it's also kind of the way in which they're doing this, right? This is not the People's Republic of China coming out or Xi Jinping coming out and saying, hey, we're going to ban this. They're doing this through their state-run media, the Global Times, which is a very common strategy they'll use. If you see an op-ed go out in the Global Times, you know implicitly that this is something that is to some degree endorsed by the regime. So it's a way of saying something without saying something with some weird level of plausible deniability or some level of flexibility. But yeah, they're saying, if this happens, then ASML risks losing access to the Chinese market, quotes, permanently. And obviously, whether or not ASML actually implements the latest U.S. export curbs is not entirely ASML's option, right? Like ASML is going to be forced by the Dutch government to do whatever, and the Dutch government may or may not choose to enforce the U.S. policy that the U.S. is asking for. So it's sort of, treating ASML a little bit as a pawn here, presumably trying to create some pressure on the Dutch government via ASML through these threats. So, it's just another day in the world of, hey, chips and geopolitics. I'm not supposed to be talking about that.
Apparently you are. I think people...
oh, yeah, that's right. I forgot.
Yeah. Well, one last story about hardware and fabrication and chips. But now over in the US, the news story is that Altman infrastructure plan aims to spend tens of billions in the US. So we covered earlier this year this big story that was covered in a lot of the media, but apparently Sam Altman had this $7 trillion initiative to build out infrastructure for creating AI hardware and doing advanced AI. That's slowly been coming into focus and kind of taking shape as something substantial. And so this article details kind of the emerging details of what the first steps to that $7 trillion looks like. And that is working to get kind of permission from the US government and getting various investors on board to start doing build out of machines and systems needed to train. So that would be tens of billions of dollars, presumably for fabrication and things like that. This is all coming out from people familiar with the matter. So it's reporting on these kind of deals that are being talked about. Nothing is signed or kind of agreed upon yet, it seems. But when we do hear more concrete news, probably will be along these lines.
Now, I got to spend more time with people familiar with the matter. They seem to just know everything. Apparently, so there's this is a very sort of, let's say, savvy engagement by OpenAI. They know that the regulators and the U.S. government writ large could come down on them pretty hard if there's concern over engagement, especially of Middle Eastern sovereign wealth funds with ties to China, which they have engaged with the UAE and other things like that. That can raise alarms. So they're trying to cover their bases and get ahead of the story, talk to the U.S. government first, get their blessing, and then do it. And part of the pitch here, as well as they say, is that other companies besides OpenAI would also benefit from these infrastructure projects. So, it's a sort of complement to the Chips and Science Act, this sort of like, I guess it was $40 or $50 billion package that Congress authorized for kind of domestic AI chip fabrication. This is sort of the more of the kind of GPU end of it, with sort of more of an AI bent to it. So it's quite interesting. OpenAI's had meetings with the U.S. National Security Council specifically. So this is you can think of this as these are the council of people who directly advise the president on national security affairs. So they're going straight to the highest levels of the executive, and it's Sam Altman doing what he does best, it seems these days, schmoozing with the U.S. government, and he's very good at it.
On to the very last section with just a few more stories, synthetic media and art. And the first story is, again, dealing with sort of conflicts within the art community and different views about using AI. The title of the story is NaNoWriMo is in disarray after organizers defend AI writing tools. So NaNoWriMo is the National Novel Writing Month. It's a thing that's been ongoing for a while, and the idea is that you write a novel in a month. And now there's an organization behind it that has stated that opposing using AI writing tools is, quote, classist and ableist. So they made the point that they don't want to restrict anyone from using novels written with the help of AI apps like ChatGPT. NaNoWriMo, by the way, is happening in November and challenges participants to write a 50,000-word manuscript. The organizers did clarify that using AI for the entire submission would defeat the purpose of the challenge. But, as you might expect, some members of the writing community have criticized the stance, have argued that these kinds of tools generally benefit the industry more than people actually using it. NaNoWriMo did face some backlash and has updated its post to acknowledge about the concerns people have with regards to generative AI tools in the writing industry.
God, and just the sheer amount of the volume of writing, that goes into the industry is so high that, like, with AI writing tools, Jesus, competing with that must be really hard. I don't know. This makes sense. I honestly don't know how I feel about this, because as a user, as a reader, rather, you're going to benefit. Eventually, AI is going to be better than humans at writing novels. We're possibly already there for a good fraction of writers, and you do want that capability, but at the same time, there is something about humans doing the writing, right? That makes it appealing. I don't know what the right math is there. Maybe divide it. Maybe have two separate competitions. I don't know what I'm talking about. I'm just pitching things,
And the next story is Tom Hanks warns followers to be wary of, quote, fraudulent ads using his likeness through AI. So this was actually a post on his Instagram, and Hanks, who, in case you don't know, somehow is a very, very famous American actor, has said on that post that there are numerous ads online that promote miracle cures and wonder drugs, and basically warned anyone who followed them that he had no association with those posts or products and that they should be careful. We've seen this happen previously. I think we've even covered another news story about Tom Hanks being used to promote some dentistry product or something. But I think, another reminder of this being very much an ongoing trend that, I don't know, luckily I have somehow managed to avoid seeing any deepfake ads to celebrities.
Oh, it's coming.
But they exist. They are out there, and I'm sure people like Tom Hanks are not very happy about it.
Oh, sorry. Yeah. You're seeing, I thought you meant somehow you have avoided being the subject of an ad.
I was going to say, big celebrity. Clearly,
I was going to say, I mean, like, literally, I mean, the podcast is doing okay, but I don't think, And apparently, if I remember, there was also a story we covered about Elon Musk being something like 80%. I hope I'm not misremembering that, but like the majority of crypto scams that do this, putting Elon in these fake videos. So I guess there are preferred celebrities for different things. Certainly, Elon is kind of crypto coded, if you will. But poor Tom Hanks, man. That's going to be a real legal headache for him to be going around suing all the companies or people who are putting these things out.
And on to the last story. It is actually more of an opinion piece, but one that I do think is worth reading. And it is titled "Why AI Isn't Going to Make Art." And this is from Ted Chiang. So Ted Chiang, a pretty notable author of science fiction, has been one of the kind of leading science fiction authors, especially on short stories in the past couple of decades. And this is his opinion piece where he lays out a case for why you might believe that AI is going to make art. And it boils down to, as far as I took away, this notion that to create art, part of the process or part of what makes it art is the process of decision making, of actually sort of having to make thousands of little choices in the creation of writing or novel, for instance. And so when it comes to something like AI generated images, it seems that if your only choice is effectively the wording of a prompt, even if the output looks like something that you may say is art, under this sort of, I guess, philosophy or framework, you would still discount it. So it's I think in this kind of field, in this discussion of like, is something that AI makes art or not art, this is a fairly nuanced and well thought out take that I found to be an interesting read. And if this is interesting to you, I would just recommend you read it as opposed to just get our summary.
Yeah, there's gotten a lot of buzz on X. I'll be honest. This is one that I had not read, and I just kept seeing it pop up in my feed, and there seemed to be a lot of pushback in the AI community about it. And I kind of see why, on the basis of the definition you shared here. Like, ultimately, the decision. Well, part of the question is the decisions are being made by whom, right? Like, yes, you as the painter or as the artist are making a million different decisions, but mechanistic interpretability might allow us to identify effectively the same number or even a greater number of decision points that are implicitly being made in circuits, in neural networks as they generate these things. And then there's just like the separate question of, sure, like you can make this argument for this way of thinking about art, but everybody has a different way of thinking about art. And it's just not super clear what this implies in practice about how we ought to enjoy something or not enjoy it. Maybe it's just one of these things where we're learning that the word needs to be broken apart into more nuance, and we need to have AI generated art and human generated art and things in between to kind of get better resolution. Because some people do care about the meaning behind it and the fact that a human made it and we're thinking things, and that these decisions were made in some kind of organic substrate, and that somehow is important to them. And I mean, I certainly kind of empathize with that, but yeah, I don't know. I don't super get the debate. I'm sure I'm missing something. But it's always struck me as being like, yep, you just need to know what you are after with art. If you just want to be stunned, if you want to have a beautiful thing in your house, like, sure, generate it with AI if it suits you. If not, if the backstory behind it matters to you, if the generation process matters to you, then yeah, go with a different thing.
All right, we are done with our short, only 90-minute long episode. And given that we've covered like 5 fewer stories than usual, I don't think we actually are that impressive in terms
on a per capita basis.
Not really. We still went longer than I would have thought, but still a fun episode. And hopefully, we have been a little out of sync, unfortunately, last couple of weeks. The episodes have been coming out a little late. So I'll try and catch up. You might hear this one just like a couple of days after the previous release.
And can I just say too, like, just because every time we do this, every next week, like the probability that my wife gives birth to our baby increases every time. And I think there's a good chance I won't be here for next week. I'm not sure, but good chance. So just want to say thanks again, everybody, for listening and for all the kind comments and especially, the nice people who commented, hey, good luck on the emerging baby. Jesus, what a choice of words. What the hell was... Anyway, thanks. You know what I'm trying to say. I appreciate it. Thank you.
Yes. Yeah. Good luck, Jeremy. Sounds like it'll probably will happen. And so we will be hearing back from you in 4 to 6 weeks or however long it'll take for you to be a regular human being again. We shall see.
Appreciate it.
And yeah, with that, we're done. As always, thank you for listening. Thank you for the reviews. Thank you for sharing, and enjoy this AI song.
It's episode 182. Last week in AI, bringing news to you. That's a 2 on the billion for SI. OpenAI's chips, California, it's watchful live. Stay tuned, so much to explore. But there on the rise, who knows what's in store? It's time for episode 182. The future in our hands and the headlines all brand new. The inland and the tech will change the supply so high. Let's dive into the stories and see how they apply.
It's last week in AI, giving you in the know. All the lectures are raised to a billion flow. OpenAI sky ships, California sets the stage. Alright, let's dive in and see how they apply. Hey! Episode 182. Last week in AI, bringing news to you. Intelligence, shenanigans inside. Headlines out, chips, cars are turning such a light.
Say it's morning, more than 182. We went to beat all like blue. Sorry, I become such a stir. Speak we like huge pressure. Lost where you used to lie. You're not attuned, just space, this trend, spotlight. When we all rise.